you by thesis123.com. I learn and teach online.
Here's the next question, number 21. A separately excited DC generator has an armature resistance of 0.1 ohm and negligible armature inductance. At rated field current and rated rotor speed, its open circuit voltage is 200 volts. When this generator is operated at half rated speed with half rated field current, an uncharged 1000 microfarad capacitor is suddenly connected across the armature terminals. Assume that the speed remains unchanged during the transient. At what time in microseconds after the capacitor is connected will the voltage across it reach 25 volts? So we have our options A, B, C and D, and all the four options are in terms of microsecond. So let's begin by writing down what's given to us. We have been given the armature resistance, the open circuit voltage. So let's write that down. RA is 0.1 ohm, and let's call this open circuit voltage as E1, 200 volts. And the generator is running at rated rotor speed. So let's say that the rated speed is N1 and rated flux is phi1. Next, the question says that the generator is operated at half the rated speed with half rated field current. So if it were to run at half rated speed, let's call this as N2. So N2 is now half of the rated, so that's N1 by 2. Similarly, half rated flux would be phi2 and phi2 would be phi1 by 2. So this is what's been given to us along with the capacitance value as 1000 microfarad. Now let's write the relation of the EMF in terms of the speed and the flux. So we know that it is directly proportional. The EMF is directly proportional to the product of the flux and speed. So using this we can write down the relation E1 by E2 is equal to phi1 N1 divided by phi2 N2. Now let's plug in the values that we have and find out what the value of E2 is. So E1 is 200 divided by E2, which is equal to phi1 N1 divided by, now phi2 N2 is phi1 by 2 times N1 by 2, and the ratio comes to 4. So using this we get the value of E2, which is 200 divided by 4, 50 volts. So when the generator is running at half rated speed, the open circuit voltage would come to 50 volts. Now we are supposed to find out at what time the voltage reaches 25 volts. So let's use the relation. This is one relation, important. The next one says E is equal to V into 1 minus e power minus t by RC. This is in terms of time and the time constant or tau RC. So here E is the voltage which is given in the question. We have been asked to find out when the voltage across it reaches 25 volts. So this is 25 volts and this V is E2, or the value that we just found out as 50. Now let's substitute these values along with the values of R and C into this equation. We now have 25 is equal to 50 into 1 minus e power minus t divided by R is 0.1 and C is 1000 micro. So this is what we have. Now let's solve this for t. We have 25 by 50, 1 by 2 is equal to 1 minus e power minus t divided by 0.1 and 1000. We can write that as 100 into 10 power minus 6. Now when we solve this for t, we get the value as 0.693 into 10 power minus 4. Now I leave the solving to you since it requires just basic algebra. So t is equal to 0.693 into 10 power minus 4. The question asks us to find out in terms of microsecond. So that would be t is equal to 69.3 into 10 power minus 6. So that's 69.3 microseconds, and this matches option B. So here's the entire solution, and I hope it has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.